Uh, Good afternoon, everyone. It's really a pleasure to be here. Thank you for the introduction. My name is Weichuan. I'm a health services research and spatial analyst at the Case Western Research University. I'm also a PhD candidate at Kent State University, so it's not a real doctor here. A little bit of the background. So breast cancer is the second leading cause of all cancers among women in 2019. And in Ohio, there are more than 10,000 new cases of invasive breast cancer with a death rate of 16.7%, about 1.2% higher than the overall US rate. And the way to reduce the risk of dying from breast cancer is early diagnosis through the effectiveness of mammography screening and the early awareness of symptoms of the patient, and also the timeliness and the effectiveness of treatment. The objectives of this study is to demonstrate spatial statistics as an effective approach to investigate breast cancer disparity in late-stage diagnosis, and to provide a useful tool of detecting disadvantaged neighborhood on health outcomes for future target intervention. We used the Ohio Cancer Surveillance System, Incident Surveillance System, OCUS, as our data source. Our study population focused on female breast cancer incidence cases in Cuyahoga County, Ohio, between year 2010 and 2015. We identified 5,385 patients. We define early stage as a localized stage and late stage as regional or distant. First, I want to show a chloroplast map showing that the proportion of late stage diagnosis by zip code. You can see the higher, the darker the color, the higher the proportion of late stage diagnosis is. But this, you can see a few clusters around Cleveland area, but do you see any problem with this map? So polygon is not equivalent to neighborhoods, and it's just created by the convenience of the mail delivery system. And there are some boundary problems. The results presented here is greatly impacted by the way you define boundary. And there could be also small number problems. In some of the polygons, you won't have enough numbers to generate a stable rate. And the other way you can look at a heat map of late-stage breast cancer. Basically, you just plot individual cases on a map and calculate the density of each cell and with a gradient of the cells and to generate the heat map. But this comparison is subjective, and there isn't statistical proof of the comparison. One way we can look at this, another way is to look at the early stage of diagnosis together. But this is kind of a reflection of the underlying population. We can look at some places whether there isn't a hotspot there, but at the late stage map, there is a hotspot there. But this is not statistical proof here there. That's why I want to introduce another techniques. We use these special techniques of spatial statistics to detect the spatial cluster, which has significantly high proportion of late stage cancer in northeastern Cleveland, and also East Cleveland and the majority part of the Cleveland Heights, with a total number of 517 patients located in an area of 3.9 miles radius. The cluster, the software we used is called StatScan, which is short for Spatial, Temporal, and Space-Time Scan Statistics. What it does is to basically compare the early stage diagnosis and the late stage diagnosis and scan the whole area of Cuyahoga County and see whether there's a high proportion of late stage cancer among all the cases. Right now at this place, that Cancer Disparity Symposium. We are inside this cluster, I should say, fortunately or unfortunately. And this is quite a large area, but the advantage of this statistical method is that you can set the maximum size of the cluster. In this case, we have 10% of the population at risk. And if you want to zoom into those specific neighborhood, you can set the maximum cluster size to 5%, and then we zoom into the area in the that covers most part of the East Cleveland and some part of east side of the Cleveland. This is the way you want to target a specific intervention to a neighborhood. Next, I want to discuss a little bit why a spatial approach is important. Many health-related researchers like to include Table 1, which describes patient characteristics with the variables at hand. But there could be many variables that the data is not available or you could never think of. In some disparity studies, I would suggest that to include a map 1, which describes the patient spatial clusters of outcome of interest. The spatial method will not be based on categorization of specific variables, just like Table 1 does. However, it groups patients by geographic locations. So people inside the detected cluster share many things in common, just like what the first law of geography stated, that everything is related to everything else, but near things are more related than distant things. So people living in the same neighborhood could ride the same bus to work and visit the same grocery stores, have similar access to healthcare, and share similar social networks and opinions. And so using this spatial approach helps adjust for unmeasurable place-based characteristics. And Table 1 is one way to look at the problem, and Map 1 is another way to look at the problem. Fortunately, we can use them together, find a way. For example, we have a Table 1 on the left, and stratified those patients not in the cluster and in the cluster corresponding to the map 1 there. Specifically, we look at this neighborhood and the late stage diagnosis. Inside the cluster, there are 45% of the patients' diagnoses are late stage cancer, and compared to 33.2% of the population not inside the cluster. And we have many other variables to look at, and I want to go with this individually. For example, patients inside the cluster, most of them, or 74% of them, are African Americans, corresponding to the same, almost the same percent of the non-Hispanic white people not inside the cluster. So this is striking. And we look at the primary payer at diagnosis. So people not inside the cluster are more likely to have private insurance, and the patient inside the cluster are more on Medicaid. And we also can use this spatial approach to look at neighborhood characteristics. So we looked at poverty level, education attainment, occupation, and vehicle availability. So basically, these are from the neighborhood characteristics that the comparison of these are really striking, showing that the patient has different aspects of access to care. And finally, we look at the neighborhood generally where the patient is located. We use the area deprivation index, which is a composite variable that uses a lot of variables from the census. And so let's compare. So the inside the cluster, we have 64% of people that are living in the most deprived neighborhood, compared to only 14% of the people not inside the cluster. And we also looked at delayed time to treatment initiation clusters, and show that on the map with the late stage clusters. This is striking because there is overlap of these two types of clusters. So these overlap. People in those areas show really different disadvantage in different aspects. But once we look at smaller clusters, we identified a new area, which is for delayed time to treatment initiation. These areas are Buckeye, Shaker, and Mount Pleasant. If you were at Ballroom A, listened to Dr. Johnny Rose, this was the area he deployed neighborhood intervention and the qualitative interview. The strength of this study of this spatial approach is that it provides alternative ways to look at cancer disparities, adjust for unmeasurable spatial component among patients in a shared location. And spatial statistics provides more strength than traditional mapping of health outcomes. And it also points out specific areas with bad health outcomes where further investigation and intervention can be deployed. Special thanks to our investigators, Dr. Johnny Rose, Dr. Saran Krokian, Dr. Jackie Curtis, Joseph Nath, Yura Kim, and myself, and Abby Stadler. Thank you very much. Any questions? Yeah, I think our team is doing a qualitative interview right now, and I am the first step to guide them where to look at. So I'm a spatial analyst here, and I really want to see what other team members say about what qualitative interviews like. Another geographic approach is that Dr. Andrew Curtis using the spatial video techniques. Like you have a camera sitting on the car and drive through the neighborhood and see what the neighborhood condition is, like how many broken glasses and the outside of the building, how the outside of the building look like, and see what transportation conditions are in that neighborhood and things like that. Thank you very much.